Welcome to this video tutorial about Trimble Business Center version 5.4, and we want to show you here how to process DJI data using, instead of the T02 file, the internet download for the baseline processing. In case you have a T02 file, I recommend you to watch the other video showing the T02 processing in TBC. We will here also follow if we hit the F1 button and we type in here in the search DJI. There's a tutorial showing here import and process DJI aerial survey data. And again, we will run here in a similar way and run here this option 2 here in 4A. So if you were not provided a T02 file to process the baseline, we can use the internet download. And this is exactly what we will do here in our process. We will follow in our video these steps here. So we will define our coordinate system. We will then define the survey quality of our geoid model, define its survey quality for our geoid model. Then we will run the import functionality in TBC 5.4 now. Then we will import with the photos also our raw data for the receiver. And also we will see how the antenna is set for our import data. Then we will take a look at the report after the data is imported. And then we can use the import internet data functionality in TBC to generate our virtual reference station data for the baseline processing. In our example, we will not measure any ground control point, which would be beneficial, but we will just use now, based on this, our result to run the relative and absolute adjustment and then generate deliverables really just based here on our RTK solution with the internet download solution. Okay, so let's start. Let's set up the project file. Here we go. Our coordinate system is in Minnesota in the United States, and we will select this one. Important, when you define the coordinate system, please go to the geoid model and assure that the geoid model quality is set to survey quality. If this is set to unknown or mapping quality, then we will struggle then with the baseline processing, because then our accuracies from our RTK solutions will not be set to 2 centimeter, and therefore then we cannot run without ground control points our relative and absolute adjustment. Okay, that's fine. This next step is importing the DJI data. You can either hit F12 and then type in import DJI, and then we will see the command here directly appear, and then we will have here on the panel on the right side the folder selection. Or if you don't go this way, you can go to photogrammetry and select import DJI UAV data, and then of course this has the same behavior. To run a successful baseline processing with DJI RTK data, you need to have specific files existing. Also again here in this tutorial, you can see here the prerequisites, and these files, they need to be in the same folder as your image data. So when we take a look here inside our file, then we can see here our images, and then we can see here the MRK timestamp file, the Ryanix OBS file, and also the event log file. And they need to be in the same folder as your images. Typically, when you run in DJI the professional version, then this is done automatically. If not, please assure that these files exist. And also please do not delete a couple of these images, because this is now for a full recording session, this data, and therefore if you remove some images, then this is not anymore associatable to these images. Okay, so we will start the import and after selecting the correct folder, you hit import. Then we see here at the bottom a bar appearing, and also the raw data check-in comes up. And we can here stick with the default settings. So in the antenna, you see this is automatically set to DJI Phantom 4 RTK. And also from the receiver side, this is then automatically importing this Rhinex patched OBS file here. So this is fine. And then this is everything just for our check in this case. So we don't need to change anything. And then we can hit OK. And then the import of the images starts. We see it here at the bottom. And when this is finished, we can continue with the next step. So our import is done. Let's take a look at the report. In the report, we can see also what we have read in. So we can see here 54 images. We can see there's EXIF information existing. Also, we have XMP informations. And in the XMP, we can see that there's the RTK flag set to 50. So this data here is already high precise. And also already the standard deviations for this images are here defined in the images itself. In the report, we also define the camera that is found. We can see here in the camera if the images are distorted or not distorted. And of course that all images here have the same size. Okay, so that's about the import. And now we can continue. We see now here our DJI images are displayed in TBC, but also, just that we are aware, there's also this Rhinex file existing with the timestamp file. So everything is ready for the baseline processing. We see the baseline process itself is not possible because we don't have now here our T02 file. We need now a reference station for this data. And therefore we will run now here the internet download for this dataset. So hitting internet download, we can then here create our internet download configuration and then search here a new site, which is then fitting to our data that we have here. You can download the most up-to-date list here, and then we will search for our recording here, existing virtual reference stations that can be used for our processing. And this is now here, I think, also the big difference to the T02. With the T02, we don't need to run this step. We always have a virtual reference station, and therefore we can always almost guaranteed process this always in the part. In your case, you are now here reliable if there are some public data existing in your area that you can rely on to run this process. And secondly, also, you can also purchase. There's also a site from the public side. You can also have your own service that you can purchase in some areas. But sometimes also the data is not only every second recorded, only 30 seconds. So here, this is where the uncertainty starts, but it's possible. And therefore, we want to show you here this run. For example, here with our data here, the closest data would be here the MNDT weight park data. But unfortunately, I cannot access this here. So either in this time frame where this data was recorded, there is no data existing that I can access. And therefore, we have to search either for a different provider. In my case here, this was then with the course data set, which is then about 53 kilometers away. And you see already the distance now will have also an influence on the quality of our result. Again, trying perhaps also make some commercial. With the T02 file, then you directly have all these information safe for your project and you can directly run it. Here in my case here, I'm here stick to whatever I can use from these predefined reference station providers. So I will use the course data, which will work for me. I say OK. And then, for example, if you don't have a public one, then you would need, for example, access code for the security. to get to the restricted data. And of course also then you would need to have the host address to access this part. I select the course, I say okay, I hit here okay, and this is here added to my part. I say here again okay, and then this will be added here to my reference stations. Then I can select this one here, I can hit automatic, and it will search now for this time span where my data was recorded. I say okay, and then it will download existing data for this flight period. And I assume this is perhaps the reason why I was not able for the other predefined reference stations to access them, or perhaps they are not accurate enough, or perhaps I don't have, they are restricted, not everybody can access them. Some of the services also are gone, they are not anymore available, so this can change. And in my case they are now here existing, so I can just stick as it is and hit import, and then the data is imported into our project. And in our case here, this is now for 2 hours we will import data, this is where my flight was taking place, and then it was here from a Trimble receiver and a single base station. So I say okay, and now we see that the baseline processing icon is available, and we can now run with this downloaded reference station our part. Important is that the reference station here is set to control quality. Yeah, so when we select here this point and we go to the properties, it's important that this point here has control quality. And let me here just go into these points and select here this value here. And when we click here on this coordinate here, then we see that this is now set to control quality. Now this is important that this coordinate is not on mapping quality or unknown, because if this is not set, then we cannot run our baseline processing. And of course you could cheat and move it to control, but if it's not the quality, if it does not have this accuracy, then of course our result will also fail or not give us a good quality. So in my case, this is the case, it's fine, it's control, so I can hit process baseline, and then the baseline processing starts. Then after it's done, we can select here on the left side this arrow key and then hit the report button, and then we can now see our solution. So we have here 782 processed acceptances, and we have here 542 flags and 240 fails. And when we take a look at the result, we see we are not reaching everywhere 0 to 5 centimeter. So we are only within 5 to 15 centimeter accuracy. And this is something we need to be aware. So for me, I got this data now for free, and at least I can reach here 5 to 15 centimeters. But with other data where I'm closer to the region where perhaps the data is more current, where I have here perhaps a better baseline solution, then I can reach high accuracies. And this is something we also need to be aware how accurate we can get the result here for our process. Okay, so with this, we can now continue our part. We save here the result, and then we are now ready to continue into our deliverables with TBC. And the process is exactly the same with the T02 now. We can now go into adjust photo stations, and we can start to run the relative adjustment. And when we start a relative adjustment, then when we have a valid RTK solution, then it will automatically also perform the absolute adjustment. Yeah? So here it's written, so if the US data includes RTK vectors, and a processed trajectory and no ground control points, which is the case for us, then also an absolute adjustment will be performed automatically after the successful relative adjustment. And this is what happens now. The type 1 extraction happens now for the relative adjustment. After this one is successful, it will automatically go into the absolute adjustment, and then we will see also the absolute adjustment accuracy. So let's just speed this up, and then we take a look at the final result. So here we go. The relative adjustment is finished, and also the absolute was done in afterwards because it was successful. So we can apply the adjustment of the relative adjustment, and also we can see now in the report, but also here on the panel, that the status is absolute adjustment applied. So let's take a short look, just that we again here can see in the block adjustment settings that our GNSS stand deviations are set to 2 centimeters, and this indicates that we have a valid trajectory for our GNSS, and this adjustment was performed based with GNSS accuracies set to 2 centimeters for this project. And then we would now need to go through all the results, how accurate everything is done and how accurate we can now run our process. This is something that we will not cover in this video, but what we want to show now is it's now possible to continue our processing by generating our deliverables without measuring a ground control point. So we can now here close this adjustment part, go to the advanced UAS, and here we can now extract digital terrain model or surface model, create here our the point cloud, creating a raster and an orthophoto. And I will finish this video just running here the terrain model extraction, and I will then also create the point cloud and the orthomosaic, and I will then just write down this into our output folder. Okay, so we will run the process, and then we will show the final result of this data set. Here we go. Our process has finished, and we will now import our deliverables into our project. And then we can take a look here at the point cloud and also our orthophoto. So let's here take a closer look in our plan view. And in the view filter, we can then here activate the display. And I need to zoom here to this data. And here we go. Yeah, so this is then our orthophoto with the point cloud. Let me perhaps remove our photo stations, and then also we can remove the point cloud here at the beginning, and then we can take here a look at our orthophoto that was generated from this data set. I hope this helps you to process your DJI data or RTK DJI data if you do not have a T02 file based with the option to download internet reference stations for our process. Have a nice day and goodbye.